Hi, I'm Justin Elliott. I'm a developer and an IT manager here at Penn State. Thank you, J. David Hester. Thank you. Yeah, I still get to develop. I'm a recovering sysadmin, so I miss the sysadmin days, but I still get to develop quite a bit, and also using Git for version control. So I felt I would like to present on that this year, and so we'll go ahead and jump in and get started. First thing, of course, please provide feedback. Good or bad. If it's bad, I'll cry a little bit, but I'd rather know than not, because I want this to be better for next year, right? Let us know what's working well, let us know what's not. If you attended the Git workshop yesterday, a lot of this is going to be a repeat for you, so if you want to step out and go something else, I will not be offended. I will completely understand, so I'll wait. Nobody? They were going to point at you as you walked out. No, that's okay. But so a lot of this is going to be about Git basics. So if you have Git knowledge and you're an advanced user, you're probably going to be bored. So the intention is, of course, to get used to the basics of Git. So let's first start off with what is version control. Git is a tool that is used for version control. It's one of the many that are out there, but it's reached a critical mass. It's been very well accepted as a fantastic tool for version control. Version control is basically a system or a tool that allows you to manage revisions of documents, files. This is very helpful for your scripts for your labs, ones that you're developing for Mavericks or Yosemite, and then you can keep separate revisions of that. Gone are the days of, and I used to do this, self-confessed, when I was developing software, I would have a folder for a new version, and that version's in there, and it was version 1.0 whatever. And I don't remember what the heck I did in that folder, right? I could keep notes inside of it, and then like I'm gonna read that, and then I have like folder, all these versions. Stop, don't do that. It's, as everybody knows, it's a good feeling to, I got all these backed up. Well, Git is a much better solution for that long term. It'll liberate you, and it'll free you of checking your documents into a central repository, which we'll talk about. Basically, a repository is that tool's system way of keeping track of the changes, simply put. And you'll also hear, of course, called version control systems, VCS, also source code management tools. Similar thing in the same vein there. I should use this. There we go. Okay. So I've talked a little bit about why you should use it. I hear a lot of people saying, well, and yesterday we had some good feedback. There were good points too, which is always nice to hear. But somebody wasn't sure why they should use it. And that's a good question. I guess they weren't convinced. And I was the same way. I thought, well, this seems like a lot of extra work to learn yet another new tool. But what I have found with developing and lab scripts, which we use in my group for managing the Mac and Linux labs, it has been huge for collaboration. We can check out what are called branches. Somebody can work on a separate script and not change the production scripts that are out in the labs live. We can say, hey, Rusty, can you check this out? And then Matt can look at it, or Gretchen, or Scott. We can all trade off, and so it frees us of, go to this AFP share, and you have a much better way of saying, Git update, boom, I have it automatically. Yep, that script works for me or not. So it enables collaboration in a huge way. I'm betting most of you in the room have heard about GitHub, and also, of course, all the projects that are hosted there. It's huge. So obviously, social coding is huge for that as well. So yeah, and like it says here on the slide, it allows you to be agile. I mean, that's a buzzword, of course, but I truly believe that, because without using source code or revisioning it at all, how many people have updated a script? It was working, and I've talked with many of you who've done this, and it's great. It looks great, fantastic. Oh, I just want to add one more thing, and then you completely mess it up. Your crash plan or something, or you're not running any backups, so you have no version to get back to, and you're like, why did I do that? I've done that. We've all done that, right? So that's another reason to use version control, because it helps you save the changes. They're safely stored away. Let others use it, and then you can update it freely, and it liberates you. I know it's funny to say that about source code revision, but it's true. It really did. So how many folks in the room have used Subversion for source code management? I was using it for a long time. Okay. I wasn't sure. I wasn't quite sure what to think about Git at first. I'm like, I don't know. I like Subversion quite a bit. It wasn't Subversion that I liked. I liked version control. Subversion, though, it kept getting in my way. It was slow to check out. You always needed a network connection. It also is a pain to move files around quickly because in Subversion, as you folks know, there's a .svn directory in every single subdirectory or folder. And so if you move everything around, Subversion got really upset about that. And editing, or rather, editing properties, ignoring files, all of that was a major pain to do in Subversion. So I was starting to look at, I actually started looking at Mercurial first. There was a developer, his name is Joel Splasky. He wrote an article that basically, and he was a diehard Subversion supporter, and so was I. And the article basically talked about his crew was trying to convince him to move to Mercurial, and, which is very similar to Git. And he finally got it. Distributed systems are here to stay. Distributed means basically that everybody who has cloned or is part of a Git repo has the full repository on their local machine. That's great because also what that means naturally is everybody has a full backup of it now as well. That's huge, right? When I first started hearing about that, I'm like, okay, that's great. That's probably why it allows Git to be so fast with really fast checkouts because it's got the local files all there. You don't have to go to the network. That makes sense. And I thought, wow, that's going to be a real mess to manage and all that. It turns out I thought it would be, and it's not, because in our group we have an internal Git hosting server. It's the Atlassian Stash, but it's just another Git hosting service. And that's our primary. Since we've all agreed that that's our primary workflow, that's the one that we always trust. I have a secondary remote, which is just another hosting service we push files to on GitHub. So that's our backup. So if GitHub goes down, I still have our primary, and I still have a local full copy on my machine. So that's the distributed part has actually paid off quite a bit.
How do you keep people from overwriting?
Sorry, Pam, what's that?
How do you keep the people who have cloned the repository from overwriting what's on the main?
So the question is, how do you prevent other folks from overwriting what's on the main? But the great thing, and we'll jump more into that later in the slide. No, that's a great question. That's fine. That's a great question. You will end up, everything that gets committed to a repository is always saved thereafter. So if somebody did make a bad commit or saved something to the repo, you can always revert back. But the better way is for that person, and you'll have to work with others on this, and just you would create what is called a branch. And then that allows them to make any changes they want. They can delete that branch away, and it will not touch other people the main production scripts, and they can experiment, have others check it out, and try it that way. So you can actually do a commit that's bad, but you can also easily revert it and revert the changes. You can see what the changes were made and track that very easily. So the last thing on Subversion, not to dig on Subversion so much, but I was using it for a long time and I just fell in love with Git because it was solved all the problems I had. The last one was branching and merging in Git is easy. It's always, it still takes a human to do the merge. I'm not going to lie. A lot of folks get the impression, oh, Git should just do it for me. It seems dangerous. It should just do that. You're right. There should be a human involved in the merging process to say, does it make sense what it's trying to merge and put back, or combining two files essentially. So there needs to be some of that. But it's a lot easier in Git than Subversion. At least it was for me. So I've talked a little bit about this. Extremely fast performance. Git is extremely quick with committing files. And because you can work completely local when you're ready, if you get back to a network, then you do a push, what's called a push. That actually copies and uploads your changes, only the differences, to your Git hosting service. So it's really fast because the local repo is there. Also, the designer of Git designed it in such a way that it's pretty amazing speeds because it's using checksums for the data integrity. So Git checksums everything with SHA-1 hash, and that means it knows exactly what's on the file system. If a file has changed at all, it knows about it. It knows of any file that's not being tracked. We'll talk about what that means, or not tracked. The nice thing about Git checksums is that you can rename a file, and if the file contents haven't changed, it knows that that's the same file, unlike Subversion. It thinks, oh, you just renamed this file? Okay, fine, I updated the name. It's the same file. And that is huge, especially if you have huge data files, larger files that are in the repo. Some you don't want in the repo if they're big or sensitive data, but the ones that are there, renaming files, moving folders around is a breeze. The great thing about Git also, if you look at Git, if you look at the documentation, you'll think, holy cow, there is a lot of stuff there, and there is. It can get as deep as you want to get. The great thing about it, it is easy to learn, and there are excellent resources out there and tools that will help you get started with it without worrying about everything else. Today we'll talk about branch and some other advanced things. Don't worry about that. Don't think, holy cow, I got to do that right away. You don't. That's the nice thing about Git. You can get easily into it and very lightweight. So we've talked about, yep, Git is distributed. All clients have the full copy so that everybody can back up each other. So there's a local repository, so as I was talking about. That's completely on this machine. You can have a Git repository entirely on your machine and never use a remote. You should, because then you can collaborate and have another set of backups, right? So that's good, assuming that server's also backed up. And yeah, so it's a very robust system. I don't have to take my work laptop home. Well, we're all working in the cloud, I realize. But Git has even enabled that even further for me. So I don't have to take my laptop home anymore, which is nice. So I have another one at home. And I just do a pull, get the updates. All right, so I've mentioned repository, and within that there's a working directory. I am going to jump into the command line. I'm also going to show the GUI applications. Some of the feedback was, and it was kind of funny from yesterday's workshop on Git, the longer one. Some of the feedback was, I'm a command line person, you should have shown more command line. And there were the GUI folks, you know where I'm going here. We're GUI folks. We want to see more GUI apps. So for those who are command line, I'm going to show some of that. For those who are GUI, that's great. I'm going to show some of that. There's a trade-off. Obviously, I can't hit everybody's sweet spot. But you'll figure out which one you're more comfortable with, and I'll show the basics of both. And it's up to you, of course, if you're interested to continue, then to investigate that further. Plus, we only have 64 minutes left, so, and I'm going to leave time for Q&A. So the repository, basically, with Git, it's just a directory with a .git folder inside of it. That's the folder that Git stores all of the data that's related to that repository. That's all that Git needs to maintain that and understand that that directory or folder is a repository. That same directory where .git resides, that's also called the working directory. So when you hear that term, that means the root of the Git folder, that's your working directory where all your files are. That's all that means. Git terminology, you'll hear something mentioning about staging area. That's not actually a file space, that's Git. And we'll talk, and there are more slides coming up about this. Staging area is basically, there's a workflow to Git. You'll have basically, you'll add a file, and you add them to what is called a staging area. Once you've added all the files to the staging area, you then move them, and you would then commit them to the repository, which saves them there. The staging area is a nice thing for collecting functionality changes, encapsulating some ideas, and we'll talk more about that. But I wanted to mention that first because that seems to hang some folks up. The reason I also have that on the slide as well, some applications today, SourceTree and GitHub, they don't actually show the staging area. The staging area is optional. You don't have to use it. In fact, it's not really necessary, but it's for some folks, me, it's kind of a nice area. And I'll show you in SourceTree why it's a nice way to work. So completely up how you want to work. Then there's the remote. What is that talking about? Well, it's not this. It's just a host, a server that you're pushing your file changes to. So when you hear remote, that's what we're talking about. And I'll repeat the terms as well. Okay, so Git has some, and you're probably wondering, why is he not jumping into the command line right away? Well, because I need to get through some terms to make sure that, and I'll do that and we'll repeat it, but I would need to mention the foundational words first so that we can then make sense once we get to the terminal, which I promise we'll get there. So Git, so there are terms, the three are. It's tracked. That means you've already added it to the repository when you did, and then you did a commit. So Git is now tracking that file and watching any changes you make to it. Okay, so it's checksumming things too. Other source code repositories tools use the change modification state and things like that. The fact that Git uses SHA-1 hashes in the files, I like that better personally. I think it's ready to catch in case I did a mod date trick or something of the file, but since it's changing the contents, Git knows it. Ignore it. You can tell Git to ignore some files. So that's actually one of the first things I recommend people do when you set up a Git repository. Create, and these slides will be available as well. We'll have them posted to our website here within the next 2 weeks probably, or sooner. Ignored, but so that would be sensitive data, large data files, disk images, things like that. Repositories, it was asked yesterday, package installers, manifest files, plist, things like that, those are perfect for repositories. Those are excellent. That's in fact what a lot of people do, and they keep track of that. Okay, so untracked is talking about, obviously, what's not tracked or it has been ignored. Untracked means that Git says, hey, I see something new here, but it looks at the files and says, if there's something new here that's not being tracked, is it in the ignores list? Yeah, don't display it. If it's not, then it's going to display it. So you will always know when there's a file in your directory when in your repository that suddenly it appeared. This has been huge for me because one of the IDEs that I use creates new files when I create a new method or a module or something like that, or a new class. It's easy to miss those files sometimes if you're not paying attention, but Git will say, hey, there's a new file here. What do you want to do with it? Oh, right, that's right, I created that. Let's track that file and monitor that. Ignored, I should mention too, the files can exist on your system. So if there are Xcode preferences for a particular user, you can ignore that. Justin's got some breakpoints for here or there. You can do that kind of information and ignore that, and it stays with the user's machine as well. So the git ignore is extremely easy to configure, and we'll show that as well. Okay, so now we're talking the Git file states. This is referring to a file that has been tracked, that you told Git, I want to add this, and I want you to track it. And then you'll tell me if it's been modified, or if it's now in the staging process, because I've now added it after it's changed. And then also, files can be then committed and safely stored into the repository, which then Git will say, your working directory is clean. That means that everything that you're tracking has already been committed and safely stored in the repository, and then you can hack away all you want. Stop me at any time if you have any questions. I'll be glad to expand on anything. Here's another way to look at the basic Git workflow. So you have your files, they're in the working directory. You create a new shell script. Then you will add that file. That puts it into the staging area. After the staging area is when you would then commit it to the repository. Then the repository is clean, nothing has changed, and you go back to the working directory state. That's basically the workflow. That's it. Now there's obviously the arrow pointing to the repository, after that you could also, if you're using remotes, which you should, that's where you would then do the push to that repository to update it and make sure you have all the changes saved there as well. All right, let's talk about how to install Git. It's actually a very lightweight installer. You can download it from git-scm.com. And then you would use the OS X terminal app to use it. Windows also has Git Bash, which actually works pretty well. I felt it was important to mention also, and I probably should have added that or mentioned that at the beginning. Git works very well, of course, on Linux, obviously. OS X and Windows. It works very well on Windows. So if you have folks that say, I'm not going to use Git because I'm on Windows, it's not going to work. That's a lie. It works. I've used it there. I have a project that I work on at home for arcade cabinets, but that's cross-platform, and it works great on Windows too, which is nice. And it's embedded with SourceTree, GitHub. I believe it's embedded with that as well. So that's also nice and standalone there. So if you download SourceTree and you just want to use the GUI apps, you don't need to install Git, actually. It'll be included with those particular applications. All right. So once you install it, this is going to be the command line version, obviously. You would use the git config command, and we'll walk through these steps. This would contain the basics you need to do here is set your username and your email. If you don't do this step and you try to do a commit, Git will politely tell you, hey, I need you to fill this information out before you can do a commit. Every commit that you make records your username and your email address. Because, of course, you want to know who did, you can blame who broke stuff or did really cool stuff. So that's an essential step to set up. If you just do SourceTree, it will do it for you. It holds your hand through that process, which is quite nice. GitHub, I believe, as well. So regarding cross-platform development, I want to talk about line endings. This is something to be aware of. Again, the GUI applications are very good about setting the correct defaults. If you do this with the command line, you need to be aware of this. The line endings debate which is better, Windows or OS X. Well, that's a religious battle, right? So for those who may not be aware, OS 10, Unix-based OSs, they use one invisible character, a line feed, for the end of the line. So every time you hit return, you're adding a line feed to that particular line, right? All Windows, there are two characters, a character return and a line feed as well. OS 9 days, they use character return, CR, ASCII, no, just kidding. That, of course, those on each operating system, it would know, oh, I'm in a text editor, make that a new line, right? So the moral here is, regardless of which way you prefer line feeds are the right way, embrace the one that is for the OS that you're running Git on. And Git will help you manage that as well. The risk here, if you don't correctly manage the line endings, is that you could have a document created on OS 10, and then you have a Windows user. And again, you don't want to give them any excuse not to use Git, right? And they'll open up a text document. Instead of seeing each individual line, exactly, there'll be a straight line of text and just think, oh, Git's broken, this is a piece of junk. No, it's not a piece of junk. You need to configure Git to tell the Windows machine, convert the line feeds to character return and line feeds, and then it displays correctly. Then the Windows machine, when you do a commit, it turns it back, and Git, without the Windows user knowing, it changes the character returns and line feeds back to line feeds. So, and I actually ran into this. I was testing this line feeds, and I had a Perl script that I was running. I was doing it on Windows and then Mac, and I took it over to Mac, and it was a setreg prop tool that I have on GitHub. And I go to run it on OS 10, and it says really weird errors, and I'm like, oh boy, what did I do? So I took it into Text Wrangler or BBEdit, and I saw that the character returns were CRLF. And I'm like, right, I forgot to undo the settings that I did here. So based on the operating system, and there are some screens following to show you how to configure this. For the command line folks, for folks using GUI, the GUI apps will do this for you again. But there are the basic three different types. True says basically tell Git to do autocorrection of CRLF, and that's where I was just talking about using it for cross-platform projects on Windows clients. So if you have an OS 10 project and a Windows, this would be used on the Windows clients. This is the setting you would use there. On OS 10 and Linux, you would use input, which is a weird term, but it basically means don't change them in it, but I believe it should change CRLFs and check it out back down to line feeds. If somebody accidentally didn't configure their client and pushed it to the repo and it contained those line endings. And then false, you'd only want to use that on a single platform project. So like if you have a Windows project and it's only on Windows or OS 10, then you can leave that as false. But the recommendation really is on Windows, set it to true. On OS 10, set it to input. This is how you would do it on OS 10. Git config global, and that's a global setting. The global implies it's for all Git repos. We'll talk about more of that, but Git can override per repository different settings, which is actually a very flexible way of configuring, which is nice. Then here it is for Windows Git Bash. So you're enabling auto, so this will actually convert line feeds into CRLF line endings so that the files look correct. All right, let's jump into how to create a repository. So the basic here is the git command, init, and then the project name, .git. You don't have to put on the .git. People do it as a convention. So if you're searching your file system, it's easier sometimes to find repository or directories that have .git on the end. You don't have to put that on, but like I said, it's a convention that some folks do. What that would do is that would tell Git create a new directory. It actually does create a new directory. I verified this because you know how sometimes you run a command and you're in the current working directory and you have a lot of other files and it just puts everything in the root of that directory and you're like, oh, that's not what I wanted. Git doesn't do that. It creates a new folder unless you tell it dot instead of project name .git. That would create a new folder directory. Inside of that, you'd have a .git directory that then would create all of the base functions, or rather the base Git files that it needs to maintain that repository. So that's how you would create a new repository locally. Git clone is when there's already one that exists on GitHub or another service, SSH, HTTPS, all of those. That would say, download it and create it in this directory that I've provided the name for. So that's how you basically create a repository on your machine. All right, I should back up quickly. Click Git clone. GitHub has a nice interface. A lot of the web-based Git hosting services have a nice function where you can say create repository, then you clone it. So you would actually create it there. It's called when it's on a server, it's called a bear repository, B-A-R-E, not bear, not that kind of bear. And then you would clone it down, and then you would add files to that, and then you would commit back up and add them at that point. Just wanted to clarify that. Okay. Want some water, Tom? Okay, yeah. Okay, that's fine. I gotta teach you a little bit. Okay, now start throwing it my way too. Okay, so one of the commands you'll use a lot at the command line is status. This is essential. This will tell you what's going on with this, what's the status of the working directory. Do I have any files that are on track that's new, or something I've modified, or if there's also a file that's been staged that I forgot about after you say that you've added to, sorry, that you have staged by saying add in the file name. So ignoring files, there's a .git ignore file. This is where I was talking about that you can ignore by path, a full complete directory, use wildcards, .dmg is a good one, .ds_store, all of those functions. The .git ignore is placed in the root of the repository directory. So if you create it, you'll see it at the same level of .get, the directory, and .git ignore, the file. You can also have global git ignores that are in the root of your home directory. And I actually do that, and I bet everybody will as well. It's a standard thing to do, where you're pretty sure you never want a .ds_store file in the repository for all repositories, so you can also do a global git ignore as well, which is handy. But the wildcards are pretty handy as well. I do this, I say not for repo, so it's very obvious. I've got some local files, and if I do a listing on them in the terminal, I say, oh, these are not in the repo because it says not for repo. And then Git is configured that way too. All right, so we talked about when you add files to prepare them to be committed, that's called staging. The command that you would use is git add -v. -v is not required, but it's verbose. It tells you what it's doing. It's nice to see that, oh, I added these things. So if for some reason you see something that, if you didn't have -v, you would still do a git status, and then you could still see what's going to be added or not in case it shouldn't be added. And there are two different methods there too. Starting with Git 2.0, which the GUI applications are not there yet. SourceTree is still using 1.8.5 or 1.8.4. It is using an older version of Git where if you did a git add, it would only add new files. Starting with Git 2.0, it now, if you've deleted any files, it includes those deletes in your staging, which actually is the preferred for some folks. So that's just a change if you're used to using Git in 2.0. The change is made in 2.0, that is. Then unstaging files. It's always scary to use RM at the command line, right? I don't like it either, but this is what Git does. This is how you would, if let's say you added a file and you didn't mean to, you could say, oh, wait, remove this from the staging area. Again, it's not touching the file system. It's not changing your files. It's removing it from that list. That's where you would type get rm cached and that file, whatever it is. And then, okay. So this is actually a handy function as well. We'll talk about what the head thing means. It's actually a reference, a pointer type thing of the last commit of a branch. But basically, I do this all the time. Let's say I'm editing the MCP application, and I'm changing some files, and I'm just want to change some debug date and time. I want to make a temporary change, and I don't want to commit it. I make the edit, I run the files, or I run the application, do the test, and then I'm done. I don't want to commit it. I want to get back to the state of the file was from the last commit. That's where I would say git reset that file, and it returns it back to what it was. That's actually a handy function to use. It's very easy in the GUI apps as well, and at the command line too when you use wildcards. Committing changes now. This is the process, as I mentioned, of actually saving the changes you've made to the tracked files or added to the staged area. I'm sorry. As soon as anything's ever staged, this is where you would actually say commit those files to the repository, and then it saves them safely. Now, I'll talk about commit here a little bit. You want to commit often, and of course that's, well, what does that mean? How often? With every single letter change I make in a line? No, definitely not. That would be insane. But don't do what I did a while back while developing MCP. don't work on something for, this is a recommendation, sorry. I would not recommend doing what I did, which is working on something for 4 hours where you've done a brilliant, cool thing, and then you completely break something 3 hours later. Now, how do you pick apart what was good and what's bad, and going back to the pieces and pulling it apart? Not fun. That's difficult because the reason you want to commit is often is because, okay, I got this particular part of the script working. That's one functional idea. Commit that. Make your commit message in English. It doesn't have to be very geeky or techy unless you want it to be. Then, now that that's been committed, move on to the next piece. And now if you mess up in any piece, you can go back to your save game state. You know, like when you're saving games, right, on Nintendo or something, right? I know I sound old when I said that. On your PS4, but you know how, when you're a kid and you cheat and you're like, oh, that didn't work. So you're doing a save game point and you want to go back so you don't lose all your lives and all the gold and the hearts you get in Zelda, right? So commit often, treat it like a Zelda save point game, and then so you don't have to keep going back and lose all your changes. Yep, and I suffered from this too, so. And the commit and the message is basically git commit -m for the message and then the commit message of what you want it to say. It's important that the git commit message doesn't just say updated stuff. Okay, that's not going to help you years down the road. And you think, why would I ever want to go look at the commit messages? I'll tell you, it has saved me big time. Because you can search in your commit messages and you can leave a note for yourself saying, hey, I had to fix and make this change. And of course, if others are watching the repository and they see those commit messages, it's going to help them out big time because they're going to say, I changed this router config because of this VLAN change or whatever. Or the MCP timer is not working when the timer is 15 minutes and it's in the morning and the pres hall one anyway. So, and it also helps you then if you're releasing things publicly for release notes. So you can say your commit message for release notes, blah, and put it in English. Then underneath that you can have the text stuff for the backstory, right? So commit messages are critical. You don't have to do them all the time. Encapsulate ideas and commit them. Doing differences, this will show you, and SourceTree does a really great job of it, and the command line does as well. Diff, you can do a file or actually commit and say, okay, now that something's been committed, what did Justin change and when he did this commit? I want to see what actually has been modified. That was huge for me recently as well. I had broke some other software that I developed. It was in the public for a couple of months, and then I ran it, and I'm like, why is this not working? Git has a really cool function called bisect. I don't have any slides on it. It's more of an advanced topic, but basically it was helpful to, it told me what's the last commit that your software was working. I told it the good state. Then I told it what was bad. And it did a binary search and it found, and I would test each time it said, okay, test it now. I'd go test the software, it works. I would tell Git it worked. And then once it got to the commit that was the bad one, my commit message was really good, and I could see the diffs of what I changed. I said, oh, that was brain dead. That's why it broke. So the commit messages are huge because of that reason. That's one of the reasons. And again, a lot of people think you have to write a book when you do commit messages. Nope. As long as it's descriptive and it works for you, just again, don't just write that stuff. Then also logging. So logging shows all of the commit messages that were made. And in this case, it's a very simple syntax. In this case, the second one is -p. I forgot what that it expands. If you do the man page on it, it will show you. But it would basically list the details, email and user ID, and then their commit message, and the last 2 commit messages. So that's one that you can use at the command line. Pretty straightforward. Git's help system is fantastic too. We'll show that. Branches I'm not going to spend too much time on because that's more of an advanced topic. And so if it was a longer session, I would be glad to talk about that. I'll be glad to talk to you, of course, after the session too. But if you ever see master and you're saying, what is this master branch? That's the default area that you're working in. Again, to get started, you don't need a branch. Don't worry about branching. Just get used to Git first. So merging, yep. So branch is basically, again, let's say you have file A, and you want everybody to just use file A, right? Well, now you want to make some changes to it. But if somebody checks out the repo, you don't want them to get what you're working on because you're not done with it. You're experimenting, right? You say, oh yeah, go check out the master branch, you're good to go. Everything there is production, it's good to go, and it's safe to put in your environment, right? What you would do is you would take that same file, make a branch, and you continue developing. When you get to, this is an example scenario. let's say you got to a point where, okay, I'm at a good point where I'd like Tom to test this. Hey Tom, can you check this out on branch whatever and see if it works for you? Yep, it does. Oh, okay, great. I've had a few other people. It's worked. Okay, great. I'm going to merge that, apply it back to the production scripts, and now everybody can check out that new version. So I safely worked on it on a branch, did some experimenting, somebody else vetted it for me, I merged it back to the main line, and now everybody else can test that script. So branching is a very safe way to experiment and update your code. It's a much better way. There's a fantastic branching model called GitFlow. Nevi, I don't forget, his last name is escaping me. Anyway, if you look up GitFlow, it's a fantastic workflow for how to handle branches. They've got, so basically, in a nutshell, they have a master branch where you never develop on. Then you, if all of a sudden, let's say your website has a problem and it's an oh, you know what moment, you would create what is called a hotfix branch, work on it there, and then merge it back to your main branch. That's one of them. And then you have development, features, releases, all of these different things. I use a version of this, but the concept is really good, and so I highly recommend checking that out. The branch commands, again, it's nice and straightforward. You would say check out the master branch. That would check out the latest commit on the master. Let's say that you have a commit that you want to actually do the hotfix. You could say check out where you're currently, what the state of your, if you do a checkout branch master, for example, you would say git checkout -b hotfix. And it would say, okay, I'm going to make a new branch and I'm going to switch to it. And now the changes I make are only in the hotfix and will not affect any files when people check out the master branch files. And then, of course, to delete it, you would just do a branch -d for delete. So I want to talk about, okay, so you may run into this. This is kind of a scary thing, and occasionally you'll hear Git show detached head, and you're thinking, what the heck is that? Ah, that doesn't sound good. I don't want a detached head. Why is it saying that? The reason it's saying detached head is that head is, in Git, is a reference to the latest commit of a branch, the top, the head of that branch. Or if it's not pointing to that, you can point it to a particular commit in a branch, which then it's called detached. So you're now pointing not to the head or tip of that branch, you're pointing to another commit in the branch. So it's trying to say, hey, just to let you know, you're on a detached head state. So if you ever see that, that's what that means. Don't freak out, but be aware that you're not at the latest revision of a named branch. Just wanted to mention that because I've run into that and I'm like, what is this? All right, we're going to jump into the command line demo, and we'll go through the commands that we just talked about. Creating a repo, creating the git ignore, add files, commit changes, review the logs, and that whole process. And check out commit is at the end if I have time to, because I want to try and get to GitHub as well, if the network works, which it's been working well for me so far. So we'll go ahead and jump in there. All right. Let's hide that. Now this is a completely new account set up this morning. So if anything breaks or bombs, I'm going to blame the demo gods. You know how that goes, right? So let's first do, and so it's unfortunate the username is also called get dollar, the dollar sign for the prompt. So that's not part of the prompt. This is my prompt. Just want to make sure everybody knows. Is this large enough? Can everybody see in the back? Is that good? Okay, great. All right, so I'm going to say git config. You can watch me stumble as I go here. User.name. No, that was my previous name. All right, so now there's the git config, and I've just configured git for the global username. And now I will cheat. Nah, it's not really cheating, I guess, but. And I'll say user.email. And yes, you can email me with questions if you want. Some. I'll help where I can. So now Git has been configured, and that's the basic thing you need to do to get started. That by typing those commands, it creates a new file in your home directory. Well, that's dot git config. And if I would, wow, sorry everybody. Oh, it's a file. I keep thinking .git directory. Apologies. All right, so in the git config, and I lied. I did actually run something else, Kaleidoscope, to get some things going. But at the end, basically what it did is, I get to use the pointer. but not outside of airplanes. That's bad, I guess. Under user, it just added this section, name equals Justin Elliott, and email equals jd6.edu. So this is the file it's changing, which will apply to all repositories. Now, if I ever have another repository that's only on GitHub, which I do, and it's not a Penn State, that's where I could override this config in that particular repo and use a different set of credentials, or username and email. All right. If you have any questions at any point, please let me know. All right, so I'm going to go to the desktops so we can see the files there. It'll be easier to get to. Yes. Oh, I'm sorry. Yeah, question. Yes, sir.
Within the Git config file,
Yeah.
that where it said kaleidoscope in that example, is that like the Git tool that you're using? So is that why kaleidoscope showing up?
Kaleidoscope is the GUI application that integrates with Git. It added some entries in there to tell Git, I am the merge tool when Justin wants to do merging. So so it automatically configured that for me and puts that in there, which is nice. So yeah, great question. All right, so Git init, what do we call it? We'll call it Yosim, I can't spell it. Yosemite, that's how I remember it. Is that correct? All right, good. Okay, yeah. I'm a programmer. Yeah, spelling's okay. All right. So I'm going to tell it. So now what it's done is it's that fast. It's just created a new folder on the desktop. And if I go into it, because the Finder doesn't show dot files, unless you change the defaults right command, you don't see anything in the directory. That's it. That's perfect. That's what you want, right? But if I do a listing on the directory, if I go into it first, I will see the .git directory. Don't touch that directory. If you do back up, if you want to back up the repository, copy everything in that directory, including the .git, except for the large files. Depends on how you want to back that up. But so that's where it is. If you go in the .git, you can look around. But what's interesting is the head reference. That's the file I was taught. That's where that information is stored. We won't worry about that right now. You don't need to touch anything in the directory. The command line junkies, if you're interested, you can look in that directory for that information. I'm a command line junkie too, so that was not a rip on the command line folks. I like it for some things too. All right, so we've created a repo. All right, so now what I want to do is I want to create a .git ignore because I have some files that I don't want to appear there. Let me jump back to terminal. All right, so let's back out. And so far there's no directory in there, so let me change. It's always fun to get it to try and do. I'm trying to make it create a, Tron light cycle, yes. Let's make it try to create a DS store file. And it doesn't, there it is, okay. And an untitled folder. So now, if I do a git status, it may not show it. Because it probably by default already has declared .ds store as built in. Git might also be aware of, and this is the Apple Git version, it might have been modified to ignore .ds store files already. But let's do something else instead. This is easy to do. Echo test. I'm just trying to make a file. That's all I'm doing here. Large data file.dat. So now I have a large data file. I don't want that in the repository. I want that to be ignored. Or I want all files to be ignored with the .dat extension. So what you could do is, forgive me for VI, or we can use VI or Pico. I'm doing command line stuff first, of course. Git ignore insert star.dat. I better put a line, okay. And I'll save that file. And now, I went one step too far on that. I'll just show you and I'll back up here. It's easy to do. See, that's where it's actually, when you make a typo, it gets very handy. It says, hey, did you mean status instead? Yeah, I did. So now it says, hey, there's a new file called .gitignore that's untracked, right? That's good because it's keeping track of all the files. But notice it's not showing the .dat file. That's because it's already in the gitignore at this point. I jumped one step ahead. So why don't I change the name of .gitignore to .gitignore soon. And now if I do a git status to see the status, it shows two files. Now it shows the .dat because the .git ignore file doesn't exist. Does that make sense what it's doing? So whenever git status runs, it looks for the .git ignore, says what's in that file. If it's specified, ignore those files that are listed in there that match. Yes, sir?
You ignore a directory, does it ignore the entire tree?
In that directory, yes. But there are times, that's a great question, thanks for asking that one. Let's say that you wanted a repository to have ignore everything in a directory, but you want that directory to exist in the repository. So when they clone it, you want that file, or rather the directory to already be created. You would create another .git ignore in that directory, ignore all files, and then except for the git ignore file in that directory. If you Google for it, you'll find out how to git ignore empty directories. But that was more of an advanced part that I added on to your question, but that was a good question. But yeah, you can add an entire path to ignore whatever inside. So let's fix this up. So I'm gonna move .git ignore to just git ignore by itself. And now we'll do a git status again. And now notice it doesn't show the large data file .dat file, because now git is tracking, or rather it knows to ignore that, and it says, hey, I still want to keep track of the git ignore file. So let's go ahead and add that. And notice that it's actually showing you right here. I'm pointing to the screen, sorry. The highlighted part, it's really handy. It says, oh, hey, if you want to track this, use git add, name of the file. I'm glad it does that, because I've been using Git for probably about 3.5 years now. And I'll forget commands all the time if I don't use the help and all this, and it helps me out at that point. So now it's added it. Now the git ignore style has not been saved to the repo. It's just in the staging area, okay? So if I do a git status at this point, clear the screen. Now it says, oh, okay, you're on the branch master. Yep, initial commit. It knows nothing's been committed. And now it says, hey, there's a new file to be committed, not yet. And then if you accidentally added it, that's where the command comes in to say get rm cached file. All right, so I'm going to say get, it's telling me up there, yep, no, commit -m, edit new git ignore file. So I put it as English. There we go. All right. So now, if I do a git status again, now that I've added it, the working directory is clean because it says, oh, nothing to commit because everything, it's ignoring the .dat file, and I've committed the new .git ignore. Yes, sir?
Use the -m.
-m is to tell it to do the message string. So, so if you type in git help space command name, and I apologize because my screen, the font's really big for the demo, but and then it'll show you. So if to get help with Git, you would type in git help command name. So yeah, it'll show you all of the nice juicy details, and there are a lot of them, which is nice. Yep. All right, let's make this large again. I'll just make the screen. There we go. Live demos are always fun when they work. All right, so we've added the files, we committed the changes, and we can review the logs now. And I have to be in the terminal for that to work. So do a get log. There we go. Now, who can remember that? The whole commit ID, right? I can't. You don't have to. Occasionally, if you're command line, you probably will use the first couple of numbers because the hash numbers are, as you can tell, pretty darn unique. And in case any super geeks out there are wondering, well, wait, what if I have two commits that have the same hash value? What's going to happen to Git? Won't it blow up? How will that work? Linus Torvald had a very good response, and he basically said, yeah, we've coded for that. If it happens, we will not commit your change. We'll say, hey, there's only a blob entry with object that has the same commit. And the fix is add a space to that script or whatever file you have. The chances of it happening are a trillion times, or whatever. So the odds of it happening are very low. I had talked to somebody about Git, and they said, I don't want to use Git because there's a Git hash collision problem. I'm like, have you seen it? Well, no. Okay. The fix is easy. I have not run into it yet. And if it does happen, you just change the file by one space or something, and then you're good to go. That's what makes Git so fast, though. The hashing and using those hash enables it to be super fast. All right. So we reviewed logs. Now we do a git diff. Now I want to see, and I need to change the file a little bit one more time to just show this next part. So we'll just go ahead and do the git ignore file. So let's say I want to add another file to git ignore. And I want to ignore all DMG disk images because those are pretty big, right? So I'll do a git status modified git ignore, and I'll say, well, I'll go ahead and do a git add git ignore, and then git status says it's staged. So now it's changed from red to green. It's good to go. Git commit -m. Now ignoring disk images. There we go. So now if I say git log, and now it shows me 2 different commits. So now let's say I want to see, well, that's nice that I see the comment. I want to see what actually changed in the file. That's where you would type in git diff, and I can say commit ID. Since it's right there, I'll just cheat and do that. Oh, yeah, I'm sorry, there's another syntax there. All right, we'll just do, it may not show anything because I haven't modified it. Yeah, I have to check out a different version. Actually, this is a great time to do that. I will show diff in a second. So I'm going to do a git. Now I'm going to do cheek. Oh, that's funny. A git checkout. I want to go back one revision because let's say I messed up the git ignore. This is where I would say git checkout and that previous. Now this is where it goes nuts and it says you've got a detached head, as we talked about earlier. It's okay. I don't like having a detached head normally, but in this case, it's just trying to tell you, hey, just so you're aware, if you're going to make any commits, you're not adding them to the most current revision of the branch. And that's okay. That's what we want, right? So if I say git, not fig. Now I'm hungry. Let's get, because there we go. Now I'm back at that particular commit as well. So it's not going to show me. Yeah, because I need to actually still edit the file. But we got to show the detached head. So I want to go back to the original master branch. So I'm going to say git checkout master. And so this previous head was that. Just letting you know, hey, that's what you're at, and now you're switching back to the master. So if I do a git status, there we go. Let's do git vi.git ignore, add something else. Really large file dot whatever. Excel, I'm just kidding. Doc, okay. So it's just another example of another really large file. Now if I do a git diff dot git ignore, it'll show me that says, oh, hey, this is what you changed. So the plus says, hey, this is a new line. This is the content, gives you some context of where you're at in the file. And then the dot plus, the green says, this is what will be committed if you made this commit. So we've done the diffs, and we've done the checkout commit type things. Sorry, we're moving really fast here, but yes, question?
So any command or any file that's going to get ignored is automatically recursive for any developer?
It's, yes. So if you, yeah, I think you're asking this. If you're ignoring splat.dmg, will ignore a .dmg anywhere in all of the tree structure? Yeah. Yes, it does.
But if I put it in a file, if I put it in a folder underneath that,
right,
it's only in that tree, that part of the tree.
It would still ignore any file that matches that extension.
But above it or only below?
Anywhere. But you can put a .gitignore in a certain folder if you don't.
That's what I mean.
Okay, yeah, oh, I see what you're saying, sorry, yeah. So if you had a folder that had a lot of disk images, but if there was a disk image outside of that and you wanted that to be maintained, yes, you can do that. You could say gitignore only in that subdirectory of splat.dmg, and then it would ignore them there, but it would not ignore them at the lower level. That's what's really awesome about Git. The gitignore system is, it's really nice. Yes?
So would you prefer to have those subdirectory gitignores, or would you do everything on like the top level? So like in the case you just gave, would you just list out the directory, or would you actually create that?
It depends. It's really flexible. Yeah, like for example, I've got a logs directory. I'm pretty sure I never want anything in that directory. But since the file's always in .log, I could either say /logs, and it would ignore everything underneath that, anything underneath that. Or I could do a **log and ignore all log files, regardless of where they're at in the whole tree structure. Whatever works for you, I would say, is that. I've made the mistake where I've accidentally moved a file into /logs, and then I miss it because it's running everything under there. It helps if you've got somebody who's slippery and it's 11 o'clock at night and you're trying to finish up and you go, there you go. Whoa, what is that file? Git will tell you, hey, file in here. Oh, whoops. So, it depends on your workflow. Yeah.
I think what he was asking is,
Oh, yeah, maybe not. Maybe I didn't answer it correctly. Yes.
Do you use a distributed structure of Git ignores, or do you use one master?
Was that your question? Oh, okay. I'm sorry. I got you guys. I use one.gitignore right now. The reason I do that is kind of related to Subversion, where Subversion you had a .svn directory and all the directories. If you move that directory around, it all hell breaks loose, and its SVN just gets ticked. And if you have a bunch of .gitignores elsewhere, you could forget about them. There's a risk of that. So because of that, I personally like to have one .gitignore at the root of the directory because I know that it's there and that's the authoritative one. That's worked well for me. So, yes?
So let's say you had one .gitignore in the root directory, and you put another one in a subdirectory with an exception?
Yes.
Okay.
Yes, you can.
The whitelist.
Exactly. Yep. You could say, I'm running out of time to get to GitHub, but yes, you could. And so that was where I was mentioning it earlier. You can say new directory, create a new .gitignore, and the way you would say is this asterisk, which ignores everything, bang, exclamation point, name a file you don't want to be ignored. So it's really handy for that. Yeah, there's lots of flexibility with Git. They thought about it, which is nice. Yeah, I keep thinking, well, what about this? Did they do this? Wow, they did. Well, cool. Yes, Justin. Yeah, you're not the only one who knows something. Well, I don't know everything, that's for sure. Okay. Let's jump in back to, so we did all of those. We created a repo, ignore, added files to stage them, committed them, looked at the logs, reviewed some diffs, and did a checkout commit to show the detached head. Yeah. Okay. I should get a sound effect. I could do a lot better than I could. Remote repos. So these, again, I just want to stress that so far I've been working with a local repository, right? This has not been on any hosted server. That would be a remote. And that's something you would push changes to, updating it, saving those. So, and then you clone, you copy down from remotes. Yes?
Server mount point, does that make it a remote?
I would not recommend server mount points. Dropbox, I know. It's dangerous to get into that because what happens is you really want to stick to using HTTPS or SSH or the Git daemon, which not many people use. Not Dropbox or something else. I know you're tempted to use it that way, but really use a free hosting service like GitHub or Bitbucket or otherwise, because otherwise, if that repository is not set up correctly with a bare repository and two people try to mount it at the same time and update it, it's not going to be pretty. You'll have issues. As I mentioned just a second ago, repositories can be over SSH or HTTPS. I'm booking because I want to show you the GitHub stuff. Self-hosted repositories. I do this at home. I've got a Mac Mini server running Crash Plan and iTunes home sharing and a whole bunch of stuff. And I'm like, I really want an SSH, or I want a Git server at home. All you need to do is enable SSH. And if you're enabling SSH and you're at the command line, you'll probably be aware of or should learn about SSH keys, key pairs, so that will allow you to log in via SSH without a password. That will enable your Git client to then automatically log into your server and download and clone without passwords, asking you every time you do a commit, what's your password, what's your password? And that really smooths out that process. I do this at home because I've got, in case I can't get to the VPN at work, my second remote repository is at home, and I have a full backup there as well. I tend to be paranoid, I know. It's good to have backups though, right? And they're small, they're tiny. The repos are very small. And so I've got it set up at home. And we were using Atlassian Stash at work, which works really well. Enterprise GitHub. GitLab is used here at Penn State for git.psu.edu for the Penn Staters in the room. So those are self-hosted. Remote repos. Yes, Pam.
So you've got, how do you keep your repo at home updated from your master repo?
Sure.
Your
Yep.
SSH
Yep. I'm doing it manually right now. So on my client, whenever I'm at home, I know that my work repo is always the master. So I'm using SourceTree quite a bit. My default push goes to what is called origin. Origin is my primary repository. I always push there first, and then I also tell it to push to the home repository as well. So I'm manually doing it right now. You could, Googling on this, have the home server automatically receive a trigger from the server at work. Atlassian and Stash can do this, I believe so. You can do Git hooks, and it says anytime I receive an update commit over here, automatically push and tell this other machine or this other server, hey, do a clone, to get an update. So when you get really, really into it, you can do that. I know you're into server stuff, so that's an automated clone or refresh is what I would definitely recommend in that instance.
So it would be a push, it wouldn't be a pull from your workstation?
Yes. It depends on how the systems work. Some of them could push to another one. If the master server, has rights to push to the other server, it could do that. Or it could tell another hook and run a PHP script or something that could say, this server, hey, do a pull. Because it could just send a messaging back and forth. Hey, I've got an update yourself. Rather than checking every minute, is there an update? Is there an update? Is there an update? So, yeah, good question. Remote repos, GitHub, all of these listed. I'll jump ahead. Cloning a repository. Accent came out. This is, like I mentioned, this is copying it down from the remote. There's the syntax for it. So git clone, the URL, and the repo name.get. The URL is probably sometimes longer depending on your setup, but it's basically that simple. That does the exact same things if you created git init repo name, but this time it's getting it from the server and downloading it. And it also then in that repo, Git now understands, hey, this is a repository that has a remote configured with it. So now if you do a commit, you'll commit locally. But that repository, when you tell it to push, it remembers, oh, this was downloaded from this server. I'll try to push. And I say try because some accounts are read-only if you're doing it from a public repo. And pushing, of course, is uploading back to the master. So in this case, and Origin's a weird name. I know, it was kind of strange. It's just the name that Linus chose when he wrote Git. But you're basically saying push to the remote named origin, which is the default one, the master branch. So change everything that's on that. And you could push different, so you would swap out master for the branch name if you're working on another one as well. Git GUI clients is a good place to go to download those. GitHub is a okay client. It's good for getting into Git. It's confusing to me because I use SourceTree and I'm just using SourceTree. They're both really good though. So GitHub, SourceTree, you can jump between both of them. When you create a Git repository, you don't have to stick with the SourceTree or GitHub, whatever you use to create that particular Git repo. Because sometimes people think, oh, it's tied to that particular GUI. No, it's not. You can use the command line and drop those GUIs all together. Tower I've not used, but I've heard it's good. Basics of GitHub demo. So we'll try to, in 12 minutes, if everybody, would you like to see a GitHub demo? Does that work? Okay, well, fingers crossed the network is working. It's been working well so far. Yes, I keep adding that on, it's funny. So, all right, we'll go ahead and jump in. So let's go to, so here's GitHub. yeah. So I've already logged in. And so I'm going to go to my home here, and I want to say, and I'm looking for a new repo. There it is. It's not very obvious. Create a new repo, and I'll call it MacAdmins GitHub demo. I'm putting hyphens in it because it probably doesn't matter, but I like to do that instead. And just demo for MacAdmins GitHub. Anyway, public is fine. So I'll say create repository. It's nice that they have an interface to say, well, git ignore. There's some standards that can fill it in for you. I'm going to actually have it add a README file. That'll be a nice demo of downloading and cloning to see that file gets created and copied down. So I'll say create repository. Yay, there we go. Now I want to copy that and clone that to my local working machine. So I'm going to go on the lower right-hand side, HTTPS clone the URL. And they talk about using all of the different methods, but I'll take that URL and I'll go back to the terminal. Oh, sorry. Not the terminal, GitHub. So I'll use the GitHub client. Oh, I already. All right, so log in, Justin D. Elliott. And where's my password? There it is. Well. Okay, I'll sign in. All right, now I'm signed in. Advanced, do we need anything there? Nope, git config. It read the git config from what I said at the command line. So it's nice it took that. I can install command line tools if I wanted to, but not at this time. All right, so now I select my phase. Where is that? Okay, it's this one. This was from the workshop. This is the one we're going to look at. So I'm going to select that, and I want to say clone to computer. Where do you want to store it? Let's just store it on the desktop. We'll just say clone. There we go. Now it's actually downloaded. Now I'm going to go to the folder, and I will see that there's the README file. So it's automatically created that file for me, and I've downloaded that. So that's how the repo works. So let's say I want to update that README. What's the default app to get it? Oh, it's on my other account. Okay, fine. Yes.
Do you have any repo that you can private?
Yes, private repo hosting?
Yeah.
Yes, Bitbucket is awesome. GitHub does it too for cost. Bitbucket, I'm actually doing that for a consulting job I do outside of work, outside of Penn State. Yeah, limited repos up to 5 people, but Bitbucket is awesome. It's really good. Oh, why are you bothering me right now? No. Okay. All right, so now this is a demo of modifying a file. Okay, so I'm going to save that file. Font big enough? All right, so now what I can do is go back to GitHub, the application, double click on this, and now it's going to show me, hey, you've got a new file. You've got 2 new lines. The green plus says, hey, new line. And then I have a second line after that that says, this is a demo of modifying a file. Well, I want to commit this change. So I could say, updated readme file for demo. And then description, I could say, added 2 new lines for the demo. That's not as, there's not much there to talk about, so it's pretty boring of a commit message, right? So I'll say commit. Unsynced commits. So now it's done it locally. It hasn't actually pushed it. Now if I say sync, it will actually say sync, and that will push it to GitHub. No file selected, nothing to sync. Now if I go back to the browser, notice the GitHub, I haven't refreshed the page yet. We'll refresh, there we go. And now it says, this is demo of modifying a file. So that's the process of GitHub creating a repo. We didn't create a git ignore there. We could have in the default setup, but I think everybody understands how that process works. We added, actually it added a file for us. We did a commit, view the diffs, it's showing that, and review the logs. We've got 7 minutes, I can show some. Basically, I will go to the folder itself. Oh, I'm sorry. Actually, that's right. It's under settings. So GitHub has a very nice interface for .git ignores. So this is where I could say .dmg, .dat. That makes sense. That would be the same file. So if I say save changes, and now I go to changes to the file system, it now shows me, hey, you've got a new file, the new git ignore file, and here are the new entries for that. So I could say, add new git ignore file, ignoring disk images and .dat files, just because. All right, so I'll say commit. That saves it locally, and then I'll do a sync, pushes it back up. And then if I go back to and load here, I'll now see there's a git ignore file, and if I can view the commits, it'll show me, here's the new commit, add a new git, and then there's the message that I just added and committed to the GitHub repository. Yes.
You made a comment on command line about the message being searchable. Is the summary as well as the description searchable?
Yes, yes, yes. Yep. You get log, and you can do regex on searches and everything. So it's really powerful what you can search for. So create repo, ignore, repeat logs. All right. So we'll jump back here. I'll skip over SourceTree and we'll go to the lessons learned. SourceTree is awesome too. I like SourceTree. If you're getting started with Git, GitHub's great. Or yeah, the GitHub application is fine. Here's what you like. So, moral is, you can see how easy it was to start simple and small. Don't be overwhelmed with all of the documentation you'll see because it's extensive and it's really good. But don't worry about all of the other whiz-bang things that people tell you about. Just do the basics and you'll end up liking it, I think. Yeah, pick one small project, anything. If you're doing Python or shell script you want to work on, just start something that's easy to do that. And when you're ready, you can use a remote. Again, you don't need to, but I like Bitbucket quite a bit. It's my favorite right now. You're set up an SSH machine at home if you're more comfortable with doing SSH key pairs. But always use HTTPS. Don't use HTTP for obvious reasons that would be in the clear. Yep. I probably said this enough. Take time to write good commit messages, make them easy to find. Be nice to your future self. You're saying, oh, wow, I'm glad I made that comment, and I can search and say, what did I do? How did I break MCP? Get help. That's the command you use to get further commands, and it's pretty straightforward there. Great man pages. They're fantastic. Resources and training. The official Git site has some very nice Git cheat sheets. They're fantastic. So that's another resource I highly recommend going to. And if you go under documentation, they're right up here. GitHub cheat sheets and visual Git cheat sheets. Those are fantastic. Those are excellent to read. So I highly recommend those. Play. Right. And on the same site, there's a Git Pro book, which is a gigantic PDF, and it will tell you more about Git than you probably want to know. But I love it. I liked it. It told me a lot of stuff. Especially, I was reading a lot when coming from Subversion as well. There's a cool website for trying GitHub. It'll actually walk you through the steps. It's a really nice training site. So it can actually say, hey, do this and that. It'll walk you through the commits and all of that kind of stuff. Atlassian has a nice Git website as well. They're trying to sell Bitbucket and other stuff in Stash. They are the ones who bought SourceTree and they develop it now. So, but they're all about Git. They converted a bunch of stuff from SVN to Git, so they're big proponents of it as well. O'Reilly has some excellent documentation and videos on mastering Git as well. Those are very, very good. So if you see a discount ready to go there, buy it as soon as you can. Looks like we have 3 minutes for Q&A. I apologize for a little long there, but hope everybody found that helpful. What questions do you have? Any questions? Yes, sir.
Is there any way to just automate, not necessarily automate commits, but automate something that typically where it says, hey, it's been a while since you did a commit?
Siri?
I mean,
you mean while you're developing, it's going to have to 30 days for habits to be formed. It would take what will happen is when you go to do the commit, and if you made a boatload of changes, that's going to be that did it for me. I'm like, oh my, because the other thing about doing commits is if you do them more often, when it's time to do a commit, you don't have to take a half an hour to do it, and you're like, I really don't want to do a commit, and then what ends up happening is your commit is junk because you're tired. I've done this. I'm like, I don't want to commit and talk about 4 hours worth of stuff, and there's too much stuff. What did I do? So commit routinely. It'll make it easier. Take 5 minutes to write the commit or less. Go get some tea or coffee or whatever. If you wait too long, the commit is going to be later a pain in the butt to write because it's going to be a lot of stuff, and you'll do a worse job at the commit message. Human nature, I think. That's me at least that I did. Tom, yes, sir.
So I created a repository. I created a project. I am now committing to that project. I'm now committing to that repository. I've discovered things like versions in GitHub and things along those lines.
Yep.
Where should I direct my attention next? Is there a next power tool that I should be looking at inside the Git hierarchy in terms of things I may not be using that I might not know about?
Branching.
Okay.
Branching and merging, I would say, would be huge for that. That would be pretty big. I think that's where you end up going, and then eventually new commands like rebase and other things too. But I'd say branching is definitely the one I would look at. Check out Git flow, that kind of stuff. Yeah.
Thank you.
Yeah, you bet. Looks like the timer just ended, so I guess that's my cue. Thank you for coming.